Alright, here we are, Project 4 CS4332, Intro to Databases. So for this video, I'll be using Microsoft SQL Server as opposed to Oracle. Still haven't got that to work on my computer yet. And the first task is going to be creating the four relations from these four figures as found in the book. Okay, so looking at the book pages, here's the first couple figures that we have. Figure 1-28, which gives the column descriptions, figure 1-29 with the data, figure 1-30 with the employee table column characteristics, and then finally figure 1-31 with the employee table data. Then there is figure 2-42 with the assignment table, or I'm sorry, the project table, and then the project table data, and then figure 2-45 with the assignment table column characteristics, and the figure 2-46 with the assignment table data. The first thing we're going to do is run Microsoft SQL Server Management Studio. And we're going to get an error, and I wanted to produce this error because, as far as I know, it's actually been happening to quite a few people, and I'll go over the really quick fix for it. So what I tried to do right now was connect to the local host server. And here's the error message. You can read through it, but essentially what it's saying is that the server was not found. Now, as far as the server being run on your local machine, it's a service. So if you were to go in and type services to your search block and pull it up, all you'd have to do is scroll down and find SQL Server MSSQL server and start that service. Alright, once that service is successfully started and you can see that it's running, you can close the services, hit OK, and try to connect again. Alright, now that we're all connected, I'm going to try to follow the book as closely as possible on this because it's set up in a logical flow, so that way when we do the primary and foreign keys, nothing gets messed up and the data can be entered pretty easily. We're going to start off by creating the database. Now, anywhere it says Microsoft Access, just read Oracle or read Microsoft SQL, whichever one you're using. And also in this case, I'm not going to be naming it this WP database. I'm just going to be using Project 4. So that's the first step. All right, so open up the Management Studio and go into Databases. You're going to right-click and hit New Database. Give it a name. In this case, I'm going to go with Project 4 and click OK. All right, now, according to the instructions, the next step is going to be to insert the department table and then using the column characteristics to create it. So the column characteristics it's talking about are these column characteristics right here. So it's showing what the primary key is, whether or not it'll accept a null, and what the type is. So go back into the Management Studio, expand Open Project, right-click on Tables, New Table. To make things easy, I'm going to tile these windows so I can read off these properties while I'm actually typing. And the first column name is going to be department name. The data type as it's read in the book is short text. Short text, as it's translated over to SQL, you can use the equivalent character or char, and since it's short text 35, you will use 35 inside the parentheses, so 35. Now it says that it is required, so allow nulls would be unchecked because since it's required, you can't have empty. And this is also a primary key, so as before, come over here and right click and set as primary key. Now, same thing, just working down the other column names. Next one's going to be budget code. And that's going to be a character of size 30. And it's required, so no nulls allowed. Next column is office number. That is also going to be character size 15, and no nulls allowed. Final column for the department table is going to be department phone, and that is character of size 12. Also, no nulls allowed. So as before, click the X. It's going to ask you if you want to save changes, and at that point we will name the table. And in this case, it was called department. And then click OK. I'm going to refresh my database view, check out my tables, and ensure that the department table is now in there. Again, I'm following the book on this, so the next task after creating the table is going to be to enter the data values. So we just completed 1.67. Now we'll be doing 1.68 to fill the table. To do that without any scripting, just right-click on the department table and hit Edit Top 200 Rows. All right, once it loads, I'm going to pull up that table again right here and just start entering the stuff in. Now, again, for this kind of action, I'm just going to fast forward everything so you don't have to sit here and watch me do it. Okay, so that does it for entering all the data into the department table. And since we were in Edit All Rows, every time I was tabbing down to the next row, all that data was committed to the database. Looking at the next step in the process, that would be 1.69, we're going to be creating the employee table. So same as before, go over to the tables, right-click New, and Table. So now, figure 1-30 is going to cover the columns that are going to be found in the employee table and their types. The first thing I want to talk about before entering any information, though, is this data type right here, auto number. So auto number, you won't find that in SQL Server here. It's not a data type selection. But what that is it's a special integer that will increment itself automatically and do so uniquely every time a new record is entered in that row. What that means is when data is entered into the table and you have the columns or the column employee number, that is going to auto-populate itself with the next number in sequence based on what you specify, which I'll go over a little bit more here in a second. So essentially what that's doing is whenever you enter a row, you could omit the employee number knowing that the system will generate that automatically. Here's how you'd set that up. So like normal, enter the column name, and then tab over to data type. Now when you tab over to data type, you'll notice that there's a column properties box that appeared down here. That's what we'll wind up using. So for the data type in this case, type or select int, and then go down to the column properties window. Scroll down until you see the table designer portion. Below that, as you keep scrolling, you'll see identity specification. Identity specification here would need to be changed to yes. So is identity will be yes. Now you'll see stuff like identity increment and identity seed. Identity increment displays the increment value specified during the creation of this identity column. This value is the increment that will be added to the identity seed for each subsequent row. If you leave the cell blank, the value will be 1. It's just the default. So what that's saying is if you said identity seed 1 and increment 1, it will start at 1 and count by ones. If you said identity seed 1 and then increment 5, it would go 1, 5, 10, 15, so on and so forth. So it's basically your starting value and your increment value. In this case, looking at the database structure and the employee numbers on the next table, 1-31, we're going to leave it at 1, 1. And this also cannot be blank, so it is required, and it's a primary key. So right click and set primary key. To speed things up a little bit, I'm going to describe what I'm about to type in here. Everywhere I see short text, I'll be using char, C-H-A-R for character, and inside the parentheses follow the numbering sequence here. Nothing else is a primary key, so I won't be setting that. And anywhere it says required no, I'll be checking the null block. Now where it comes time to enter the number, I'll be using int because the long integer in the remarks column here refers to a 4-byte integer, which in Microsoft SQL an int already is 4 bytes long. So I'll just be using a regular int. All right, that does it for every column in the employee table. As I had stated before, if it is required no over here, the nulls will be checked. The number is just an integer, and all the other short texts translate over into characters. So hit the X, click yes to save, and then enter employee. And click OK. From here, I'm going to refresh the database real fast and check to make sure that our table is now in there. And there it is, employee. Okay, looking at the book, the next step, 1.70, is to create the relationship and referential integrity constraint. So the referential integrity constraint, whenever you see that, that's just saying it's a foreign key. And that's going to be between department and employee table. Will enable the enforcing of the foreign key, the cascading of data, but not the cascading of data during deletes, only updates. And I'll go over that when it comes time. To create that foreign key between the employee and department table, go down to the employee table, right-click, and click Design. Then go up to the Table Designer, click on that, and click Relationships. Since there are no current relationships, it'll be blank, and we just want to add one. So go down and click Add, and I'll leave the name the way it is for right now. The first thing to do is specify the tables and columns. So expand Tables and Column Specifics, and click the triple dots. In this case, the primary key table is going to be the department table. The column within the department table that is the primary key is going to be department name. Make sure employee is the table selected next. Then choose the column within employee that's going to be the foreign key to the department name. In this case, department. Click OK. Now, here's the part about the cascading records and cascading updates and cascading deletes. In the foreign key relationships box, scroll down and go to the Insert Update Specifics. Expand that, and now you'll see Delete Rule and Update Rule. Looking at task 1.70, we're going to enforce foreign key integrity when cascading data updates, but not when cascading data from deleted records. In order to do that, come down to the Delete rule and hit No Action, make sure that's selected, but then Update, we're going to want to cascade. Once that's all done, click Close and close the table. It's going to prompt you to save the table and, of course, save those changes. Here it will tell you that it's going to be modifying the department employee table because that's where the foreign key and primary key constraints were made. So hit yes. All right, now I'm going to go back in and I'm going to refresh my database, which leaves the last step of entering the data into that table. For that, I'm going to look at the book again and make sure I can get all this data up front. Oh, looking at this, there's one other thing I wanted to mention. So back in step 1.70, this note right here is saying we will not create the recursive relationship for the foreign key constraint between supervisor and employee number in the employer table at this time. So what that's referring to is that this supervisor column right here that has 1, 4, 6, 10, 12, Those numbers are supposed to be a recursive relationship identifying who this individual's supervisor is by their employee number. So if you look at Mary, Mary is employee number 1, the CEO. Mary does not have a supervisor, which is why that's allowed to be null. Okay, but Rosalie Jackson, their supervisor is 1. So that recursive relationship, which we'll set up later, is basically saying that their supervisor is Mary Jacobs. So any number you see in the supervisor column here is the corresponding employee number for their supervisor. Alright, so on to the mundane data entry. I'm going to expand the databases, expand project 4, go into the tables, right click on employee, and hit edit top 200 rows. Now, something I have to note at this time is that when we set up employee number, that was set up as what was known as the auto number in the book. So that auto number that we had established with the increments, when it comes time to enter data manually, it will not let you physically edit this column. If you look really carefully, this null is actually a little bit gray. If I attempt to type anything in there, which I am right now, it's not going to take it. Meaning this column you cannot edit. It's going to do it automatically, and that was the whole point of using that, as the book called it, the auto number system, where every time a new row is added, it's going to input the employee number with the increments and starting number that we had provided, in this case being 1, 1. So as I go through and enter all this text, I will not be entering employee number. However, every time I tab down to the next column, you might notice that the employee number is automatically filled, and that's the system doing exactly what we told it to do. So I'm going to enter in the data for the first row, but obviously can't put anything in for employee number, and then once I tab down and commit those changes, you'll see the employee number auto-populate. And there you see it auto-filled the number 1. Now, as I fast forward through all this, you'll consistently see me not enter anything into the employee number, and then once I tab down, that'll be auto-filled. Alright, so that does it for all the data entry, and as you can see while I was going through, the employee numbers incremented by 1 each time I hit tab on the final column when I was entering the email address for each row. With all the data entered, that takes care of step 1.71. So the next thing we're going to have to do is enter the 2 tables from the chapter 2. I'm going to collapse this database, close this, and then we'll switch over to here and get started on the second portion. The next step in the project is to add the project and the assignment tables to the database. So looking at the book, I'm going to be going over these steps right here. So the first step it has is to create the project table using the column characteristics in figure 2-43. This is what I'm looking at right here, this section. So 2-43 being this table right down here. So per tradition, we're going to create a new table, and to do that I'm going to go into my project 4 database, right click on table, hit new, and then add the column names. In this case, we're going to have project ID, that is the type int. It's going to be a primary key and it is required, so we're going to uncheck allow nulls. For that primary key, right click, set primary key, and then go down to the next column, in this case project name. And as we saw before, it's going to be character of size 50. And it is required, so we're going to uncheck null. Department. Character of size 35. Also required, so uncheck. max hours. So this is a little different because it says in the book, it says number 8, 2. In this case, though, we're going to have decimal, and we're going to use the same precision, though, 8, 2, and then uncheck allow nulls because it is required. Next column is start date. Type date in this case. To find type date, you can hit the drop down box here, and it has date right there. You could have typed date as well, but I want to show you that there are multiple selections. This is not required. It says required no, so we can allow nulls and keep that checked. Next column, end date. Also of type date. And allow nulls is checked because it is not required. And with all that, we'll hit close. And we yes want to save. And this is going to be named project. Hit OK. It saves. Going to go back up here, refresh the database, and then make sure that all my changes were saved. And there's the project table. Okay, going back to the book, the next step here, 6.26, is to create that foreign key between the project table and the department table. Special note here that the cascading of data updates will be enabled, but the cascading of data from deletes will not. Okay, so looking back at this diagram right here, you can see that between project and department, the department name will be the primary key to the foreign key department in the project table. So from here, we're going to go into the project table, right click and hit design. From there, go into the table designer and hit relationships. We're going to need to add one. And again, this is going to be between project and department, the primary key being in the department table. So go over to the tables and column specification and hit your triple dots right here. The primary key table is going to be right here, the department table. So select department and then select the column which is the primary key, in this case department name. And then the foreign key is going to be in the project table, the table we're currently in. And the column that it's going to be a foreign key of is department. So click OK. And then again, when we're talking about that whole cascading portion, expand the insert and update specifications. And you're going to want to look at the book again, just because it's going to change in the following tables, but in this one it's enable enforcing of foreign key and cascading data updates do not enable cascading data deletes. So the update rule will be cascade, and then the delete rule will be no action. With that, close it. Close this down. It's going to ask if you want to save, and then prompt for saving of both the department and project tables. Hit yes, and that does it for number 2.62. Looking at step 2.63, it's simply adding the data to the project table using figure 2-44. So I'll bring up figure 2-44. Being this right here, and then like normal, we're going to add that data to the newly created table, the project table. So I'm going to right click on that just for easy data entry, hit edit top 200 rows, and then go through and enter each one of these pieces of data, but speed it up so that way you don't have to sit through it. Alright, well that wraps up all of the data entry for the project table. Taking a look at the book again, the next step, 2.64, using figure 2-45 with the column characteristics of the assignment table, create the assignment table. All right, so figure 2-45. All right, the assignment table. So a little bit to say about the assignment table. It is unique in the fact that it gets both of its primary keys from other tables as foreign keys. Now, there's it's such a thing as a combined primary key. I'll go over what that does and how to use it in this case. We will first establish the primary keys between those two columns and then later make the relationships linking them to the project and the employee table. So going back to SQL Server Management Studio, we're going to create a new table. So I'll close this one down, right-click New Table, and then starting off with the column name, Project ID. The data type of that is just going to be integer. And it is required, so we're going to uncheck Allow Null. Next column name, employee number. That is also of type integer, and it is required, so uncheck null. Then finally, hours worked. Here is where we get into that decimal type, and we're going to mimic what the book has as 6,2 for its precision. And that is not required according to figure 2-45, so we're going to allow the nulls. Now, here's where you get into the composite key, as I said before. So project ID and employee number as a combination will make up the primary key. So in order to do that, what you want to do is you want to click on the first column name that you'll be using as a primary key, then hold Shift and click on the other one that's going to make up the composite key. Then, like before, right-click and hit Set Primary Key, and you'll see both keys pop up here. Finally, hit the X when it asks you to save the table. Of course you do, and then name it Assignment. Click OK, and then it will close. From here, I'm going to refresh the database, and let's check it out. And there are our 4 tables. These next two instructions from the book, 2.65 and 2.66, is where we'll be setting up those foreign key constraints. However, one will be using cascading of data from deleted records and one will not. So let's look at the first one, 2.65. This relationship is going to be between the assignment table and the employee table. So looking back at here, the assignment table and the employee table, it's going to be the employee number from the assignment table that is a foreign key to the employee number column in the employee table. So let's do that. Go to the assignment table, right-click, and click Design. Once it's loaded, go to the Table Designer and click Relationships. From here, click Add, and then in Tables and Column Specification, lower it and click the 3 dots. For this case, the primary key exists in the employee table. As it said in the instructions here, it's going to be between the assignment and employee tables. So since we're dealing with assignment, this is going to be where you put employee. Drop down and go to employee number. Now in the assignment table, it's got both the employee number and project ID because we had set it to 2 foreign keys. For this one though, since we're only dealing with the employee number primary key, set this top one to none if it's there, and then keep employee number as the second one. Hit OK there, and then scroll down. In the Insert and Update Specifications, this is where we're going to have to read. As it states in 2.65, we're going to enable enforcing of the foreign key constraint, but do not enable either cascading updates or cascading of data from deleted records. What that means is both of these right here, the enforced replication and the foreign key constraint, are yes, and you want to keep these as no action. I always expand it and make sure that it says no action, so that way it doesn't accidentally become cascade or set null, and you don't know it, and then add that constraint. And that goes against what this rule relationship wants. So with that done, hit close. Close out of the table assignment itself. When asked if you want to save, click yes, and you'll see employee and assignment tables will be getting their update. Click yes, and then we're back over here in the Database Object Explorer. Looking at step 2.66, we're going to create that foreign key constraint between the assignment table and the project table. So go back into assignment, right click, design, and then use the table designer relationships. Now it's going to show you the one we just created, and that's great. However, we do have to add a new one. And under this new one, it's going to be, instead of the employee table, it's going to be with the project table. So the primary key in this case is going to exist in project. And if, again, you're curious as to what the primary keys in there are, you could go back here or look at the table design. In this case, it's project ID. It's seen right here as well, so project ID. And like last time, you want that to apply to the project ID column in the assignment table, but not the employee number. So click none on that, and then hit OK. Now this is where we'll have to read carefully again. On step 2.66, it does read that we're going to enable foreign key constraints and cascading deletes this time, but not cascading updates. So for enabling cascading deletes, you're going to want to go down to Insert and Update Specification, and then where it says Delete Rule, that's where we have cascade. Because again, it said right here, enable enforcing of referential integrity and cascading of deletes, which is right here, cascading of deletes, but do not enable cascading updates. So here's where it says updates and it's no action. Once doing that, you can click close and close down the table so it prompts for a save. Yes, we want to save, and then apply that to both project and assignment. So click yes, and that is it for that table. Next, we need to enter all the data into the newly created assignment table. So I was looking at the assignment table data here and saw that it was selectable. So I'm going to hope that we can cheat just a little bit, and also this will give me the opportunity to show you sort of a built-in insert into function for tables inside Microsoft SQL. So to do this, we're going to go to the assignment table and right click on it. Now down here there'll be a script table as. We're going to want to perform a series of inserts because we want to insert all that table data. So go to Insert To. Now here you could create a SQL file, you could generate a clipboard, basically like if you copied some text, or you could do a new query editor window, which is what we're going to select because we're going to execute the query once we're done. So click New Query Editor Window. Now what it just did was generate a stubbed out version of the insert into script. To better see what's going on, I'm actually going to format this a little bit differently just by deleting some of the hard returns here, just so it looks a little more clear what the format is going to be like. So as you can see, here's the columns project ID, employee number, and hours worked. And then down here in the values section, if I delete everything, you'll see the alignment of those sections. In fact, I'll bring this in just a little bit. Okay, so what we're looking at here is when we do the insert into the database object being the assignment table, currently in the project for database, it's specifying which columns to use, in this case project ID, and then employee number, and then hours worked. Now, in this sort of stubbed out version, it gives you the values inside of parentheses and with your brackets, and then the name of the column that it is, followed by the data type. Now, these are all numeric, so when we insert the values, we won't need to have any sort of quotes. But essentially, what's going to happen here is we're going to enter a number, and this won't be the correct number. But we'll enter like a number in here, and then after the column you could enter another integer, maybe employee number 12, and then their hours worked in a decimal format. They might have only worked, say, I don't know, 10.10 hours, right? Now, this would be an acceptable way to insert these values into the database. What we're going to do, though, is we're going to try to insert all of these values all at once. Now, to do that, you would have to use another comma and then a second set of open parentheses, and then put your values in between the commas like such. And you can do that over and over and over again until you have all the values. So with that, I'm going to copy and paste all the stuff out of this assignment table and see if I can't kind of roughly format it so that way it would insert correctly. So let's try this copy paste and see exactly what crazy format Adobe has. All right. I'm going to do it right before the go. Ooh, that is quite ugly. As you saw, the first row up here in project ID was put above the text. I'm going to get rid of that text there. And it looked like everything was going great. Like in these instances, we'd only have to add some commas in between, and that would have been awesome. And then somehow things got a little bit out of whack. And instead of doing it in this row format, it just did all of one column and then all of the other column. Not ideal, but I'm going to try to work with that as best as I can, again, to make a good example. So real quick, I'm going to transcribe these numbers, this 6 all the way down to this 8 next to these numbers right here, delete them, and then do the same thing for the hours worked values. Okay, now same process. Now that I've got those numbers in there, I'm going to go from the 40 all the way down to the 45 and transcribe them next to that set of numbers that I just got done doing. Cool, so everything is almost in the correct format. Essentially, we just need to put everything within the parentheses and separate the values by commas. So what I'm going to do in that case is, well, first I need to get rid of this example up here that is no longer of any use to us, and same thing for this one. And again, to make sure everything can be seen, what's going to happen is there's going to be a parentheses on either side. On the right hand side, there's going to be a comma to separate the individual value sets, and then commas in between everything. Once that's all done, we'll execute it and hopefully won't get any errors. And everything now matches the format of project ID column value, employee number column value, and hours worked column value. These are giving this syntactical error. I don't understand why, because again, it was its own generated stubbed out code, and everything is falling into place as far as the values go. There's a comma in between each value set, the set being in between the parentheses, and then the final value set doesn't have a comma following it. So let's execute that, and we should see a return statement of how many rows were inserted into the database. 30 rows affected. So with that, I'm going to close out this SQL script. If you wanted to, this is a good time to save the changes to it, should you desire to create this data set to put into a table again. Otherwise, click no. And since that was the assignment table, I'm going to right click on it and edit top 200 rows and see if all that data I just got done typing in actually appeared. And it does indeed look like it's all there. So I'm going to close down this window right here and shrink everything up over in Object Explorer, because the next thing we're going to do is those non-trivial SQL queries that are listed in the homework assignment. So in the Get Ready project, that is the examples: where equal, where not equal, order by two attributes, group having, join two tables, and two tables by grouping. It also says that they have to have at least 5 queries doing join, subquery, or view. So that's going to be the next major section in this project. So with that, I'm going to open the book back up and then also open SQL Server Management Studio. So what I found on page 128 was a bunch of example SQL queries, and reading through a lot of them, these particular ones that I highlighted seem to work very well with some of the required queries we have to perform for this project. What I have here is a set of queries that correspond to what was in the book. As you can see, they're highlighted D, G, H, I, and N. The other ones I kind of handcrafted to fit what was being asked of us. And the other way you could read this is when you see plus view, plus join, and plus subquery, those are the added portions to the query that will fulfill the objective of the 5 join, subquery, or view portions. So this first one, the where equal, where I used a view. What projects in the project table have not been completed? Show all information for each project. All right, so what you can do for this is open your database up and go to Project 4, go to the tables, and since we are concerned with the project table, you can start by right-clicking and go to Script Table As. This is sort of like a shortcut. And then what we're looking for is a select statement. So go down to the select to, and then new query editor window. Okay, once it's done processing, you'll see the new query window right here. Now, I'm going to dissect this a little bit. It's asking what projects in the project table have not been completed. Show all information for each project. So because we want to show all information, although it defaulted to including every column, you could replace all that with just an asterisk, because that is essentially a select all. And then the next thing is from the database object table project, which it already established because we right-clicked on project to open this window in the first place. So now it's what project have not been completed. Now, what you could do is you could look into the project table to get an idea of what's going on. To do so, right-click project and hit edit top 200 rows. And you can see that there's a start date and an end date, right? Now, it's asking which project has not been completed, and that's going to be whatever one has a null in the end date. So that's what we're looking for. That's going to be our qualifier. So for this, you would type where. Now, if you open a set of brackets, we're looking for end date. If you start typing it, the system will automatically pull up elements that would match. In this case, end date appears. Now, if you look to the left, this icon means that it's a column, which is what we're looking for. We're looking for values inside the column end date that are null. Now, from here, since we have to establish it's a null value, you would not use the equal sign. Instead, you'd have to type is. Because null is not technically a numerical value. It is like literally in the database, nothing. So you would type is null. And once that's all done, you can execute it. And we should see that one project where the end date is null, and that corresponds to this row right here. So I said we were also going to use the view command here. Now what view command does is create a view that can be referenced later on. It's almost like creating a sort of function that will display values that you know you already want to search for. In order to do that, since we already know that this select statement works great, it's right down here, you can type in create and then view and give the view whatever name you see fit. In this case, I'm going to say Open Projects. And what that's going to do is create the view known as Open Projects. Now you can run this and it will create that view for you to reference later, or you could create the view and then run the view all in the same query. Oh, before I go any further, what I forgot was an as, because you're creating the view open project as this select statement. I'm sorry, this select statement right here. I'm going to want to do this all in one SQL query. So afterwards, I'm going to run another select, but this time use the open projects view that will have been created right prior to it. So here you type from, and where normally you would call out the table that you're looking into, in this case you would just type open projects. And as soon as I started typing it, it recognizes that that is a view that I've already established up here, so I'm going to double click on it. All right, after that, to execute this, you can hit this button right here, execute, or F5. They both do the same thing. In this case, I'm going to hit F5, and the query executed successfully. So it produced these results because what it was selecting from was here, but it also created a view. Now if you were to run this again, it would yell at you because you're essentially trying to create a view a second time, and I'll demo that really fast. So I'll hit execute, and it's going to give this message down here saying there's already an object named open projects. That's because the first time you ran it, it created a view, which is an object in the database. So the second time you ran it, it tried to create that view again with the same name. Now, you can see those views because you go into this folder here under Project 4 called Views, and there's the Open Projects view that we had just created when we ran this script the first time. So again, to demo that, you could delete this view, hit OK, and then when you run this again, it'll successfully execute because it's recreating the view and then calling on the view for the table. And there it is. It recreated the view in here, and it's going to call upon it. At this point, to fulfill the requirements of the project, you'd want to take a screenshot of this script right here, or possibly just copy and paste it right into the document you're going to submit, and also take the results down here. Again, that can be a screenshot. I'm not sure that these tables copy and paste very nicely into Word. I wouldn't take the chance that he accepts screenshots, though that's what I'm going to do. Let me collapse all this stuff and close this out. I'm not going to save this SQL script. You could, though, if you'd like. I have a couple that are saved, and I'll use those later on. I'm also going to open up all the other tables just for reference for these upcoming scripts. Now about those scripts, anytime you run a SQL query, you have the option to save the script file. It's just a text file with the extension SQL. I'm going to open a couple that I've already got made for this project, just so that's less I have to type, and then I can better explain what's going on. To do something like that, you can go to Open, and then just go to File, because if you have SQL files, script files, it will recognize them. In this case, I'm going to take well, all of them, 2 through 8, since I've already done number 1. And just click open. Now what it's going to do is it's going to go through and open all of those and put them in my tabs here. You can access those pieces or those tabs by just clicking down here, and you'll see all the tables, views, and anything else you have open in the tabs. So this next one, number 2, where not equal. So I made this script from doing the same process on the last table where I right-clicked and then scripted table as for select, and then just kind of started filling things in. Now I've got a couple comments in here. You can add comments by doing sort of like a double negative sign. But what this is asking for is to display the employees that are not in these three departments, so administration, legal, and human resources, and show all information. So that show all information again is a select asterisk like that, and I've got the quote from the actual project description. Then the from, in this case it's going to be the employee table. It's the employee table because that's where the employee information is listed that would have that kind of information. Some of the stuff you're not going to know off the top of your head. That's why I kept these open the whole time I was doing this, so I could look into the employee table and say, oh yeah, all right, well, employee table actually has their department column in there, so I can use this table. So going back to the script, I use the employee table, and now because this is a not equal, I have where not, and then department equals administration, right? Because that's one of the departments that we're not concerned about here, or that we don't want to look at. We want to look at everybody that's not in these three. Now, just for teaching purposes, I also used two other ways of saying not something all in line here, and that's basically your greater than, less than signs put together in this fashion right here. That's like saying and department is not equal to legal. And then right here, adding the and operator, department, again, is not equal to human resources. So all of these do the same thing. Not department equals, department with the greater than less than sign, and then your exclamation equal sign. They're all interchangeable. I could have wrote and not department equals and not department equals on both of these. It all means the same thing. I just included all three methods so you can see that it does exactly what it's supposed to. So once you have something like this, depending on what kind of not equal statement you're looking for, you might only decide to go with one not equal qualifier, or use a different table completely. But I'm going to hit execute. And again, what I got is everything that is in the employee table, and hopefully I don't see any departments that are administrative, legal, or human resources. It doesn't look so. This only returned 15 rows out of however many the employee table has. The employee table has 20 rows. So that means there's 5 rows in there that were of the administration, legal, or human resources. On to the next one, order here. So this one was more complicated than I initially expected, and that is because what the book is asking for, where it shows project ID, project name, all of these columns, those columns come from, I think, 3 different tables. And for me, I wanted to make sure I got all those to display as the book wanted. So in order to do that, I used a series of joins. But let me run you through this real quick. So all of these selects, where you have the table followed by the column, right? That is a standard syntax here, where I broke it up into what tables they're coming from. So everything's separated by a comma. So you have table project, column project ID. This is again what's going to be displayed in the results. Table project, column project name, and then project table, department column. Again, there's a comma. Now you could have put all this on one line, but visually I like to break it up so I know, hey, this next column is coming from a different table, being the department table, and then finally the employee number is coming from the employee table with the last name, the first name, and the office phone. Now, as an example of how the system, tries to interpret what you're wanting and gives you a drop-down menu, if I wanted to add another column, say from the employee, and I open my brackets and start typing employee, I'll see employee right here with the symbol saying, hey, this is a table. So all you have to do is double-click. And now as soon as you hit dot, it's going to tell you every column that's in the employee table, which makes it really easy. If it's got a lot of columns, you might have to scroll or just start typing to search. But if I wanted anything else in here like position, I could just double click and put that in, and then it would appear in my results. course, that's not what I want, so I'm going to get rid of it. I just wanted to show you how the system can kind of be intuitive when you start typing these tables and these columns. All right, so here's the tricky part, right? When you get time to start joining everything, when I looked at what it was asking for as far as the employees assigned to each project, right? I looked at all the tables, and it turned out the assignment table, because that has all the project IDs and the associated employee numbers, I made that my primary, or what you could say is your leftmost table. So that's why I have select from assignment, right? Now, I had to join the other tables, and I'll bring up the image from the book here, because the assignment table here has foreign keys from the project table and the employee table, right? So what I had to do was join the employee table onto the assignment table where employee number equaled employee number, because that's the two objects that are shared, or not objects, but the two column names that are shared, and one's a primary key and one is a foreign key to that primary. So that is essentially going to stack one, or not stack, but lay that assignment or that employee table right next to the assignment table when the results are produced. If we were to get rid of all this select stuff and just put an asterisk, it would be much more clear, because then you'd see a like where the columns from one table met with the columns of another table, met with the columns of another table. So anyway, that right there is just joining the employee table to the assignment table. Now, next I had to join the project table also to the assignment table. Now, the reason for all these joins is because you need to see or access the columns from those other tables here to get the information from all the employees, right? So that's why I'm having to join them. I need all of those tables because they're all part of the problem in the book, where it wants the project ID, project name, all these. It wants all of these columns. So in order to get to those columns, I had to join the tables together. All right, bringing the that little diagram back up. The department table also had to be joined. Now, the department table, as you see here, could have been joined on the project table or the employee table, because that department name links to either of them. However, I decided that I was going to attach it to the project table because it's the project table that is coming off of assignment for the project ID, right? Because it's asking, when you look at the question is asking for what employees are assigned to each project, right? And that's why I decided to attach that department, because we also need the department phone, right? And that's really the biggest part about that, and it's the only reason it's even attached, is in order to get the department phone itself. As you might have noticed, the assignment table, although I use that as my primary table here, none of the columns are actually displayed in my select statement. So none of these start with assignment. That's not what it was looking for. However, I had to take the assignment table because of the data it has, right? It has the data on who, being employee number, is working on what project. And that's exactly what the question was asking for, is, let me see if I can pull it up so I can read it to you verbatim, who are the employees assigned to each project, right? So that's why the assignment table in this case was my primary table, because it contains that data. I just had to link it because, I mean, it's not asking for this. It doesn't want the employee number. It doesn't want the project ID, right? That's not what it's asking for. It's asking for the employee's last name and first name. It's asking for project name. So in order to get there, you have to join those tables. And again, in this fashion, where I have the primary keys of project and employee number tables and the assignment foreign keys. That's why I chose assignment as my first or leftmost table in this case. So once all those are joined, I decided to order by the project ID ascending. I don't think that was a requirement of the problem itself, but let's give this a run and you'll see what it produces. So here is the table as it wanted it, according not that Word document, but as it wanted it according to here with project ID, project name, department, department phone. Here we go, project ID, project name, department, department phone. So everything down here is in the order that the problem specified in the book. Now, as a real quick example for again, like learning's sake, if you wanted to see what all those tables looked like smashed next to each other with everything displayed, I just wouldn't specify any columns. I would just delete all of these column specifiers right here and give it an asterisk and then run that, right? So still 30 rows have been returned, but now you have the project ID, employee number, hours worked. These three columns right here, those make up that first table. Those make up the assignment table, right? So project ID, employee numbers, hours worked. And then the next table in the join, right? Because first we had assignment. The next table to be joined to assignment is employee. So if we go and look at the employee table, right? It's got this employee number column all the way through email address. So going back to the results, here's the employee number column all the way through email address. Well, that was not a shift there. So all of those columns are the columns that came from the employee table, right? So then we have this this next one starts with project ID, right? So I'm looking at joining the project table onto the end of all this, right? And project is the project ID through the end date. So you go back to the results, and here you'll see project ID, and there's the end date. So those are all the columns from the project table. And then finally, we have the department table here, right? And that department table was connected where the not directly onto the assignment like these other ones were, but onto project, because there's nothing linking. There's no similar fields between the department table and the assignment table, but there are similar fields between the department and the project table, and that being the department column and the department name column, right? So here we see department name, and again, that's going to start the department table, and it goes all the way to department phone number, it looks like. So there's department name all the way to department phone number. So again, this is not what it's asking for. This was just me showing everyone how those columns of each table are connected onto the end of the previous table that's brought in by the joins. All right, that wraps it up for this question. On to the next question. Order by two attributes. For that, I'm going to be using the fourth SQL query that I have saved. The main difference between this one and the prior query is that this has a where clause for the department in the project table equaling sales and marketing. And that's because in the book, the first one was just asking who are the employees assigned to each project, and then this next one is who are the employees assigned to projects run by the marketing department. So that's why that where is now there concerning the department equaling sales and marketing. The other thing is, because this is supposed to be ordered by two attributes, I added this little portion to the very back side of what the book had given that says then last name in ascending order, and that's this portion right here. So let me just tab between the two of them. This was number, sorry. Oh, that was number 3. I modified it but never saved it. There it is. So with all the select properties in there, this is number 4. And as you saw, the only thing that changed was the where and the ascending order. Now again, what that is doing is that's joining the tables that we saw in the figure in the book onto each other, so that way I can access like all the row information, and adding the where clause is just further filtering it, because that's what the book wanted. So should I go and run this? we'll see all the employees that had worked in the sales and marketing department projects. So that's the 8 rows that you see down here. And if you were to compare this to the assignment table, you'd see that these are the employee numbers because they've been joined that are associated with this department. Let me pull up the next question. So the next question is just a simple group, right? How many projects are being run by the marketing department? Be sure to assign an appropriate column name to the computed results. So we're going to be using the computed results here, and that's going to look like this. So we're selecting department in the project table, right? This is the computational portion. It's where you're counting department as total projects. All right. Now, whenever you do something like this, when you're adding adding a column by a specific name, which is what the as is doing here, you're saying count some stuff and call it this, right? So this is going to add this column called total projects. Now, whenever you do something like this, those columns are going to also need to be grouped by. If that wasn't there, the script would not run. So again, the projects being run by the marketing department, I went into the project table, and we'll take a look at that real fast. Right, because the projects have all unique IDs here, and then it associates their department. But of course, there can be more than one production. There can be more than one sales and marketing. There could be more than one finance. Let me go back to the script. Now, what this is asking for, though, is how many projects are being run by the marketing department, and that's why that's why the count is on the department, and that's why they are grouped by department. Of course, the filter here is sales and marketing. So let me run that real fast. We should see that sales and marketing has 2 total projects. Now, if this question had asked something different, like say accounting, because I think accounting only has 1, if that script were to read something like instead of sales and marketing, we insert accounting, wow, with an extremely long amount of spaces in between, I predict that the total projects will only be 1 because there is only 1 in that table. And there it is. Again, we can look at another department that has more than 1, and I think sales and marketing is one such department. So I'll take that. Oh, no, I'm sorry. Sales and marketing was already the one we did. So we'll do production. And then go back to this script that I've got prepped and put production in there. Execute, should see 2. Oh, and you can also check out the note I have here, must group all columns when using math operators like count, sum, average, so on and so forth. The next question, group having. I decided to use the subquery on this one, and you'll see why here in a second. This question is asking which projects have 5 or more employees assigned to them. Group by project name. Now, again, I wrote this one myself because I figured it would be kind of easy to implement a subquery on it. Let me show you the tables again. Right? So I'm looking at project because project table has the name of the project, and that's how I wanted it to be grouped. And then the assignment table is where it contains the personnel assignments to each individual project. So you can count, let me pull that up, the assignment. Using the correct operator, you could count how many are of project ID 1000, how many are of project ID 1100. You can count those, and of course what I'm looking for is anything that's more than 4 in my example. Now, I wrote this script so that way it was only returning 1 column, and I decided to use the project name column, but instead use it as this long projects with more than 4 people assigned. Again, it was just easier to do it that way instead of selecting a whole bunch of columns. Now, here's where it gets tricky. Normally, the where would be, say, project ID, and then you'd say like equals something, right? Like project ID equals, say, 1000, or some concrete number, or maybe multiple numbers, right? But in this case, you're saying where project ID in, and this is where the subquery comes into place. Now, CS-wise, think of this almost as a function that's going to return something. In this case, you're selecting project ID, right? And you're returning what you've selected. So what we expect is that you'll get, multiple project IDs here, or maybe just one if it qualifies. And then that is going to be passed to this major where. So you have your first query where, and then it's going to associate the project ID with whatever this returns. Now, for an example, I'll just copy this stuff right here so you can see what I expect. Now I'm just going to go to new query and plug this in and then execute it. Now you might have noticed that everything in here is underlined in red. That's because the SQL Server Management Studio defaulted to the master database, but none of these tables exist in the master database. So what you'd have to do is go ahead and select Project 4 from that and then execute it. And what was returned was the project ID 1000 and project ID 1400. Now those are the two values that will be passed into this project ID where clause, right? So what we expect is that we'll get 2 returned here, and that's what's going to be counted because they're grouped. Now let's execute it and see what happens. But let's execute it, of course, against project 4. And here's the projects with more than 4 people assigned. And again, this Q3 production plan and Q4 production plan would have been the equivalents to 1000 and 1400 in the project ID. So the next problem is one I got from the book. However, the book asked to join 2 tables. I decided to join 3 tables simply because it's the book question, write a SQL statement to join employee assignment project. Well, obviously that's 3 tables. And in this case, join on is not relevant for SQL Server Management Studio. Instead, we'll just use an inner join syntax and then run the statement. And so that is my 7th. And again, that's attaching employee assignment and project. So looking back here, you have employee assignment and project. Because assignment has foreign keys related to both project and employee, I decide to make the primary choice here as assignment. So it's from assignment. And then attach the employee table and the project table onto assignment. Now, again, this is sort of like dealer's choice as far as the syntax goes. You could potentially put this assignment employee number on the other side of this, and it wouldn't change the outcome because you're just saying where this table, this column, is equal to this table, this column, regardless of where they're positioned in what order, left or right of this equal sign here. So here is the segment where I attach or inner join the employee table right here to the assignment table. And then this inner join is where the project ID, the project table is being joined to the assignment table. Now, of course, they share, in this case, project ID between project and assignment, which is why we have project ID here and project ID here as the columns. And then between employee and assignment, it's employee number in assignment as seen here, and then employee number as seen here in the employee table. I ordered this by project ID in ascending. I don't think it asked for that. I'll double check real fast. Nope, it just says run. I just do that because I like to see something that I can logically order just visually. So again, switch this database. Here, let me show you what happens if it doesn't. Oh, it auto-selected a project because we hit use project 4. Also, a good thing and a good teaching tip there is that when you use the use command, it will automatically, or it will script a database change. Whereas if you were to just run a new query, it's going to go to the default database if you didn't already have one selected. So that's why it's kind of important to use the use command because that way you can ensure what database you're currently working in. Otherwise, it's just going to run it against whatever database you currently have selected. It's just good syntax, much like always using the table dot column number. In a lot of cases, when you're only dealing with one table in a single script, you wouldn't have to put the table predecessor just because it's already kind of assumed that since you're only dealing in one table, that anything that's not part of this like dot operator here is a column within the table you're working in. So just to illustrate what's going on, again, we joined assignment. So assignment is the far leftmost, and that would be these three columns here. And then we joined employee to that, and employee is employee number through email address right here. And then finally we joined project, which is the project ID column through the end date. The final question that I wrote myself is this two tables by grouping. What are the total number of hours worked on each project? Show the project name, department, max hours, and the total hours worked. Group by project name and ordered by max hours ascending. Be sure to assign the appropriate column name to the computed results. So it sounds complicated, but it's not too bad. I'll walk you through the select portion. So I asked to show project name, department, and max hours, and those all come from the project table. So here I have the project table dot the column being project name, dot the column being department, and dot the column being max hours, and that covers those three. The next part is and the total hours worked. That's why I have this sum statement here. So that goes into the assignment table because the assignment table contains the hours worked by each individual. And let's look at the assignment table real fast. So the assignment table also has a unique key of project ID. That means that for the project ID that's or when you group by project ID and you sum, it's going to sum the values from here to here, from the 30 to the 75. Now, since it's grouped by project ID, it'll sum only the values present right here, and so on and so forth. So back to the script, I want to give that column that's actually doing the summing, a special name, and I set it as total hours worked. Again, that's like what I decided it was going to be named. Now my primary table is the project table, and I did a join between assignment and project, and I'll pull up that graph once again. Assignment and project, they share that product or project ID, which is why we have the project or on project as the table dot project ID equals the assignment table dot project ID. So wherever those are equal. And now here's where I get into the group by again, with project name being primary here, then department, and then max hours. Again, because the project names are directly linked to the project IDs. So the point I was trying to make earlier was that whenever you have a sum or a mathematical operator up here in your select, those columns are all going to have to be grouped by. I know it makes not a lot of sense at this point because essentially you're going, well, what do I want to group all of them for when really you're only looking at like the project name as the primary. You know, the department and the max hours wouldn't really matter. And truthfully, in this case, they wouldn't need to be grouped together visually. But syntax-wise, they do. So I'm going to run this in the correct way first, and you can see the outputted results. And here you see each project name. Again, it's going to be grouped by project name, so you won't see any two of these being the same. And then the total hours worked that was calculated from the total hours column in the assignment table. Now, here's where it can go bad. Say I did not add this group by right here. I'm just going to cut it out of there and try to execute that. Right? It's going to say that it's missing that column because it's, well, let me move over here so you can see it, either in an aggregated function or the group by clause. And as you saw, I just removed it from the group by clause. So this max hours select in the, or this max hours column that was in the select statement, because we have this operator here, the sum assignment, all these columns now have to be part of a group by. Because I took it out, that's why it's complaining so much. Now if I put it back in and delete that comma and click the right button, we'll get the proper results. Let's go back and look at the homework assignment. The final part to this is the ER model at like figure 2-42. Now that just so happens to be this. So if you want to use ER draw, feel free to do so. I know I already gave a tutorial on how to do the ER draw. If you want to cheese it though, Here's how you cheese it within SQL Server Management Studio. Go down to the database that you want to do the diagram in, then go to Database Diagrams. Right-click and hit New Database Diagram. Now, if you've never done this before, it'll give you this prompt because you need some support objects and it will automatically generate them. If you've used the database diagrams before, it will not give you this message. So click Yes. Now, for this, we want to add all the tables that we currently have to this diagram, in which case you can Shift-click and hit Add. All right, once it's done, it'll show you that there's no more tables to add, so you can just hit Close. Now, this is pretty straightforward. You really just have to organize them in the fashion that you see on this table right here. So assignment being somewhere over to the right, department being over here to the left, and then employee being somewhere directly down below here. Now, the cool thing about this is you can, in fact, move these. So I know this is leading to department, so you can put department right there. This is department name, which is a key right there. On this side, it's also going to department there. You can drag this over. Of course, it's not going to agree. There we are. And then drag it down. There, that works a little better. Now over here on this side, this is going to project ID. And over here also on project ID. And then finally employee number. So I'll just move this up to employee number. I'll move this around because I need to clear some space. And then down here to employee number. All right, well, unless you want to separate these two over here by maybe putting one off to the other side, which is perfectly doable. Other than that, you have your diagram made within SQL Server Management Studio. I hoped you enjoyed the video. I apologize for not going into more depth on some of the joins and group bys and maths. Those are really, they could be entire videos all in and of themselves. Other than that, I will see you on the next project.